Hi again, class. We're still talking about the graphic display of data. This is a part 2 video, and I'm on slide 7 of the PowerPoint presentation, but actually it's a PDF file. I'm on slide number 7 of the PDF file called Displaying Data Graphically. Slide number 7 is a frequency polygon, and frequency polygons are really, really important because this is what distinguishes them from most other displays of data. They can show us the shape of a distribution of scores, what that picture or distribution actually looks like. The concept of shape is going to become really important in a few chapters, so that's why we're introducing shape now as a concept. The frequency polygon that you see on slide number 7 is pretty easy to interpret. There are two axes. Axes are just the governing rulers, if you will, of a particular graphic. In this case, the horizontal axis is called test score, and below it you see a number of test scores starting with 35, then 45, 55, 65, on through 175. And what those test scores mean are really arbitrary. We'll just consider them the number of points that students received on a test, for example. So that's the horizontal axis, test score. The vertical axis is called frequency, and as the word implies, frequency, that is simply the raw number of, in this case we'll assume people, the raw number of people that achieved that particular score. This graph isn't perfect. It's not, or I shouldn't say it's not perfect. It's not precise in the sense that we have to do some sort of estimating if we want to know more precisely how many people achieved a certain test score. But looking at the frequency polygon, it looks to me like very, very few people had a score of 35, and I can see that by how low the line that makes up the frequency polygon, the shape, how low the line is on the graph. It's pretty close to 0. When I look at the number of people that got a score of 45, a few more got a score of 45, not many more, but a few more, and the line is increased, is up higher than where the line is for people that scored 35 points. Then somewhat more people, about, 17 or 18, had a score of 50. It looks to me like about 61 or 62 people had a score of 65. It looks like about 110 had a score of 75. It looks like about 150 had a score of 150 people had a score of 85, and on down the line, literally the line, because it's the line that presents us with the shape. Now, this particular shape doesn't really hold much meaning for us right now because we haven't contextualized what the shape might mean, but essentially it's I would classify this as very approximately normal, and we'll talk a little bit about what normal means later on. But moving on to slide number 8. One of the nice things about frequency polygons is that it's possible to show more than one distribution at a time, like the slide on number 8. We see the frequency polygon, or the shape of the distribution for two variables, a variable called large target, that's blue if you're looking at this in color, and small target, that's red. And we can see where the two distributions overlap. And then presumably the horizontal axis is called time, and the vertical axis is called frequency. So these are the number of cases and the amount of time that it took to hit a particular target. Slide number 9. This is a histogram. As I mentioned in segment number 1, histograms can also help us determine the shape of distributions. Histograms are pretty similar to frequency polygons, except we're dealing with vertical bars rather than dots that are connected by a line. But the concept is the same. And as you can see from the graph on slide number 9, on the horizontal axis we have score. We'll just consider those test scores, if you will, arbitrary test scores. And then the vertical axis, frequency, are the number of people that got that particular score. So you can see it looks like one person scored between 0 and 10. 2 people scored between 10 and 20. 3 people scored between 20 and 30. 4 people scored between 30 and 40. 5 people scored between 40 and 50, and then the trend continues downward on the right half of the graph. Now, this particular graph, just FYI, I would consider to be fairly normal. Slide number 10, a single variable bar graph. Looks kind of like a histogram in the sense that we're dealing with vertical bars, but the difference is that we're displaying not numerical data, not the frequency, or in this case the defects per 1,000 cars, according to the graph on slide number 10. We're displaying the frequencies for 3 factories: factory A, factory B, and factory C. If you look at the bottom of the graph, the horizontal axis is factory, and so presumably these are 3 different factories that we're displaying the number of defects per 1,000 cars produced. It looks like if these were real data, that we would be best buying a car from factory B, I suppose. Slide 11, another bar graph. Simply, and I realize it's not in a great amount of focus depending on how large you have this graphic. Some purists insist that bar graphs should be displayed horizontally, as this one is, and so I just use this slide to show you the quote-unquote appropriate method of a bar graph, and then horizontal. Slide number 12 is another horizontal bar graph that's showing 2 different experiments or interventions like that. Anyway, the bottom line, just some summary comments regarding the graphic display of data. As I mentioned toward the beginning of the first part of these segments, the main rule when it comes to producing a good graphic is clarity and honesty. In other words, a graph should, for all intents and purposes, stand on its own. It shouldn't take a lot of effort to fully consume the information that a graph is trying to present. I also, just in concluding this segment, I also wanted to make a point of noting that I don't consider all these graphs that I shared with you via this YouTube and PowerPoint to be perfect by any stretch of the imagination. They have flaws in and of themselves. I mainly just wanted you to have a chance to see some examples outside of your chapter, some examples of particular graphs and what they mean, and how to identify them. So that's really the main point of these segments in the PowerPoint.